Again, if this was a competitive exam, it would be timed. There'd be other people in the room with you, and you try to do the best you possibly can in the questions that follow. Now, these are, let's see, there's 5 questions. Seems like the pattern here that we give you 5 questions. I'm going to say for the most part, you probably give students about 60 minutes to work on these things over here. Now, certainly some are easier than others, but you don't know that until you try it. But you have a feel for certain things. And what I mean by that, if you like logs better than you like trig, you do the log before you do the trig. If you like inequalities, do the inequalities first. If you like work problems, do the work problem first. You have a preference, but what you're looking for is low-hanging fruit. Now, for me, number 1 appears to be a pretty simple question. So if I were doing number 1, I'm saying that, if I did that, I want to remind myself of things I know about this. And I know what they're asking for. They're asking for the domain and range of the problem over here. So if I were doing this over, I just remind myself, for the invertible region of the cosine function, we're talking about an invertible region now, it's well established that the x would be between 0 and pi, and the range of it, this is a domain, by the way, the range of it for the function, f of x, is between -1 and 1. And I can write the inverse down now. Well, the inverse name is arc cosine of x, and its range, I'm sorry, I didn't even put range down first. I want to be consistent in my language. The domain of this thing is the range of the other guy, so the x here is between -1 and 1, and the range of this thing, and that's f inverse now, is between 0 and pi. So let's go to town. And what I'm going to do over here, I'm going to point out to what I'm going to do over here. This guy here, I know what it must be. 3x minus 12 must be between 1 and -1. And this is the domain of the problem now. Can I solve that? I can. And let's go through that. I'd add 12 to all sides. You would get 11. You get 13. And then I divide by 3. You get 11 thirds, x, and 13 thirds. And this is the domain. So the domain of this problem over here, I'll write an interval notation, is between 11 thirds and 13 thirds. We'll check the key later. Now I want to do the range of it. And what's nice about the range of it is I'm looking at it, and the most, let me point out what I mean by that, the most this could be, the most that could be is pi. That's the most it could be. So what does that mean? The most it could be is 2 pi minus 1. That's the most it could be. What's the least it could be? Well, the least it could be is 0. All right, let's write that down. So 2 times 0 is 0, so the least could be -1. So this is the most, this is the least. Let's put the range down now. What's the range going to be? -1 up to 2 pi minus 1. All right? Now let's look at the case, see how we did. And this is problem number 1. And number 1, let's see if we answered the question correctly. It says the domain, 11 thirds to 13 thirds. Let's go back over here. I did pretty good there. And what's the range of it? They said the range between -1 and 2 pi minus 1. And we did good there as well. All right? So I'm going to say number 1, super low-hanging fruit. And I'm glad I did that first because it was really something that I could do very quickly. All right, let me erase. Again, I want to point out these are videos. You can always pause the videotape and just copy down if you need to copy down. All right, 2 looks a little tough. 3, I dislike the problem, to be honest with you, because inserting symbols and getting this thing to work out might be a challenge for me. But I want to try number 4. I think 4 is low-hanging fruit. And what do I notice about it? I notice that's an inequality, and the first thing I notice about it is 1 plus x squared is always greater than 0. So I can multiply both sides by 1 plus x squared. I'll do that. And again, we're doing 4 now. So 1 plus x squared times 1 minus x squared plus x4 minus x6. I'm multiplying every side by 1 plus x squared. You would get 1 Over here you get 1 plus x squared, 1 minus x squared, plus x4, minus x6, plus x8. I'm going to multiply it and see what happens, right? I'm hoping for something really simple, by the way. And what do you get over here? Let's write this. Get 1 minus x squared, plus x4, minus x6. I distribute the 1 across. Now the x squared is going to cross. What do you get? X squared, minus x4, plus x6, let's see, minus x8. All right, whoops. I'm going to keep going. And let's multiply this side out. What do you get? Let's see, you get 1 minus x squared, plus x4, minus x6, plus x8. I distribute that across. Let's do the x squared. What do you get? X squared. Let's see, minus x4. Let's see, plus x6, minus x8, and then you get plus x10. Well, I got to simplify these sides, by the way. And what do I see? It's something really nice, by the way. See, 1, there's a lot of cancellations, by the way. And a lot of cancellations over here, by the way. And let's write down what we get. We get 1 minus x8. Things are moving along pretty nicely. And I get 1 plus x10. Now I'm going to I subtract 1 from all the sides. And what do you get? Minus x8. You get 0. And over here you get x10. Now what I notice about this thing, this is really simple to look at now. What do I know about these things over here? This is true for all real numbers. Now how do I know that? Well, look at it. I mean, certainly look at this over here. No matter what real number I choose, you know, negative, positive, 0, it's always greater than or equal to 0. And no matter what real number I choose over here, like 0, 1, minus 1, it's always going to be, less than or equal to 0. So it's true for all real numbers. So this is satisfied for all real numbers. All right, you can write that down this way. You can say x is, or you could just simply say x is an element of the real numbers. All right, let's look at the key. Again, we're just kind of working through this over here. By the way, 1, they give you some additional information, but no, they're not asking for that. 2, I did not do yet. 3, I did not do yet. I just did 4, and it says it's true for all real numbers. All right, I'm going to go back over here, and what I want to do is, whoops, I go too far there. I'm going to start to erase my chicken scratch. Again, if this was a competitive exam, I wouldn't be erasing my work, by the way. Including if my work was nonsense, I still wouldn't erase it. What are we going to do now? I'm going to look at it, and I'm looking at the remaining problems, and it doesn't look that bad, but it's kind of annoying to me, the logs, and this over here, inserting symbols, but we can do it. And then, whoops, I just did 4. I don't want to do that again. That would be crazy. I'm looking at 5, and I kind of enjoy word problems. And what I notice, it says 2 candles of equal length. I'm going to put a picture of that down for me. So a candle here, and a candle over here. They're equal lengths. And it says they start burning at the same time. It says 1 candle will burn completely in 4 hours. So the rate at which this burns, it does actually 1 candle every 4 hours. All right? And then it goes on, it says the other one takes 5 hours. So this one will burn out. It'll consume the entire candle. I'm going to say 1 candle every 5 hours. So I got to be honest with you. This one here is going to be the one that shrinks fastest. All right? When you light those candles, this thing's going to burn much faster than the other one. All right? But I wonder what their question is. It says 2 candles of equal length start burning at the same time. One of the candles will burn completely in 4 hours, and the other in 5 hours. How long will they have to burn? Well, I don't know. So I'm going to say T is time. How long will they have to burn before one candle is 3 times the length of the other? Well, let me write this down. And I got, certainly when I put this down, I hope you know what I'm putting down. I'm going to say, the first candle, it starts out with 1, but then if I let it burn over time, I'm going to say it's going to burn at a rate times time, right? And the other one's going to be 1 minus 1/5 of a t. All right? But what did they say? They said one candle, right? You have to be very careful about one candle, 3 times the length of the other. All right, and this is where people get really confused. 3 times. How long will it have to burn before one candle is 3 times the length of the other? All right, so this could get really confusing to students. Let me just kind of, just a candle here, candle there. Right, so I'm looking at this, I'm trying to get an equation now. This is really confusing part for a lot of students. I'm thinking about it, and I know that one guy's going to be smaller than the other, and this is going to be the smaller one. Once they start burning, it's always going to be smaller, but I want it to be that, all right? So whatever this thing is over here, there's going to be some point in time, it's going to look like this over here. I don't know what's going to occur. Let's see if we can solve that equation. I'll go back and read it later, and I'm going to multiply both sides. Nah, you know what? I'm going to straightforward multiplication. 3 minus 3/4 of a t equals 1 minus 1/5 of a t. I'm going to multiply both sides by the LCD, which is 20. And what do you get? 60 minus 15t equals 20 minus 5 into 20 is 4, so 4t. Wow, I got some work to do, don't I? And let's take a look at this over here. I'll take 20 from both sides, that gives me 40, and add 15t to both sides, I get 11t. And now I know what t is. What's t going to be equal to? Let's see, 40 divided by 11, which is 3 and 7/11 hours. Let me go back and see what their question was, though. Right, so how long will they, well, I figured that part out. Give your answers in exact hours and approximate the whole number of values in hour, minutes, and seconds. So I got my answer. I got 3 and 7/11 hours. I'll write this down. But they want me to get it in a better format, because that's really bizarre when you speak that way. So I'm going to say 3 hours. And this is 7/11 of an hour. And I want to get that in terms of minutes. So it's going to be 60 minutes in every hour. Hours cancel. 7 times 6 is 420 minutes over 11. Let me do this. 11 into 4, 2, 0. Let's see, that would go in what? 3 times, right? 33. That gives me 90. 8. 8 times 11 is 88. And I get a remainder of 2. So 3 hours, 38 minutes. We'll look at the key later. And now I'm going to do the seconds. How many seconds do we got? It'd be 2 11s, right? Let me just think if I did that right. 88. Yeah, 2 11s. Well, that's minutes, right? And now it's going to be 60 seconds in every minute. Minutes cancel off. I get 120 over 11. Let's do that division. 1, 2, 0. That's 1. That's 11. Hope I don't make any mistakes, but we'll figure it out. And you get 10 here. That's a 0. I'll put a decimal point over there. Decimal point here. And, well, it looks like 9. So that's going to be what? That's going to be 99, right? Well, I think I got it now. And what is it? 10.9 seconds. Well, that's about 11 seconds. This is approximate. It's not exactly that, but it's approximately that. And that's reasonable. Let's take a look at the answer. And this is number 5, right? And I want to point out, I know it's hard sometimes. I find it hard too, just to even remember what I read. But 3 and 7/11 hours. Let's go back to that. Make sure you know I wrote that down for you. I got that. And 3, 38, 11, right? Oops, 3, 38, 11. We did pretty good. All right, so I'm going to go back, and my confidence is shooting up at this point. And I want to point out that I'm just going to get my eraser out because, I'm just practicing at this point. I'm not trying to show someone my work, except for the people listening. I'm hoping as you're listening, you're also working or listening and saying, do I want to give this a try a little later, see if I can remember what he said. All right? So let's take a look. And let me get my eraser out. And erase this doohickey over here. And erase my work over here. And again, you can always pause the tape and copy my work. Right? It's got a finite space to work on. That's why I'm erasing my work over here. Right? But there's evidence of that work. You can just rewind the tape and you'll see the evidence of it. All right, so I want to point out, I really dislike that 555 business over there, and there's spaces between the numbers. But here's the problem. When I said there's a problem, you might say, I don't know what to do with that. But I'm now looking at, I want to point out what I've done so far. We've done one. That was low-hanging fruit. Super simple to do, by the way. But if you knew trigonometry was simple. I did 4 and I did 5. And now I got these 2 remaining problems over here. And again, I always find, problems like 3 to be challenging because I got to invert symbols with that, and I look at it. But again, I'm not saying it's unique either. You might say, no, I found a better way than yours. But, I'm kind of looking at it, and I don't know, I got to think about it. And thinking about it, I'm going to try something. I'm going to try inserting symbols over here, and I'll leave myself some spaces. Whoops, sorry about that. I'll leave some space over here to insert the symbol. All right, I'll put this down for you. 5, 5, 5, and 5. And I want that to equal to the number 19 in the end. I'm kind of wondering, what could I do there? And what I thought of was this. And let's see what we get over there. That would be 4, right? If I did that arithmetic, that would be 4. And now what I'm going to do, I'm going to, it says on the left-hand side, according to insert grouping symbols. Well, let's put in a grouping symbol now. And I'll put a factorial symbol there now. So again, what does that give me? That gives me 5 minus 1, which is 4. And 4 factorial is 4. Let me write that down for you. 4 times 3 times 2 times 1. Well, that gives me 24, right? Oh, gee, what is it going to be? That's a subtraction symbol. So I have it, and I want to make sure I read the instructions. They may say don't repeat things, but let me take a look and see if I got. They said on the left side of the equality, you may insert grouping symbols. I did that. Carets, I didn't insert any caret. A caret's an exponent, by the way, for exponentiation, along with plus minus, a multiplication symbol, division symbol, and a factorial symbol to make the statement equality. We did. We made it an equality. And this is one answer. Now, again, I'm not saying there's not a different answer. There could be. I'm not looking for them, but you may. You may say, oh, I can find out all the possible combinations that would do that for me. I'm just going to get one. I got one. All right, now I got to go to this other one over here. And I saved it for last. And I'll be honest with you, the reason I saved it for last, it looks kind of complicated for me. So it says over here that A and B are positive numbers. I'm glad for that because otherwise I got, logs that are much more difficult to deal with. We're dealing with a real number system. And everything looks fine. If A and B are greater than 0, everything looks fine to me. Now, one thing you could do, you could just rewrite it and figure it out. But they also go on to say that this is true. All right? So someone says, why is that important to me? And I'm going to claim over here, maybe it's not important, but I'm seeing things in it. I'm going to write this over here. And we'll go one step at a time. So A squared plus B squared is equal to 7AB. And I'm starting to see something now. And what I'm seeing is that maybe there's a perfect square in the problem. So let's write this down. A squared plus 2AB plus B squared, I just added 2AB, right, would be 9AB. All right, this is a perfect square, which is A plus B squared is 9AB. with the understanding that A and B are positive numbers. Now what I'm going to do is take the log of both sides. So log of A plus B squared, right, would equal the log of 9AB. You know what? This may not lead to what we want, but I'm going to give it a shot. I'm seeing something now, at least. And I'll tell you what I'm seeing over here. I'm going to erase my work over here, by the way. But again, you can always pause the tape and copy what's written down if you want. Or just watch tape again. You can do that too. So I'm going to go to the next step, what I do, and use rules of logs now. And let's write this down. So this is going to be 2 log, whoops, A plus B. And this would be log 9 plus log A plus log B. I'm just using rules of logs over here. Well, again, I don't know if I'm going to get it, but I'm seeing something now. What am I seeing? I'm seeing 2 log A plus B equals, well, log 9 is actually 2 log 3 plus log A plus log B. Well, I'm going to divide both sides by 2 now. What do you get? Log A plus B equals log 3 plus log A plus log B over 2. I'm getting really close. All right, I have this part. I don't have the other part, though. So I'm going to subtract now. So log A plus B minus log 3 is going to be log A plus log B over 2. I have it now. What is going to be? Log A plus B over 3 equals log A plus log B over 2. Let's see if we did that. And yeah, we did it. All right, I'm going to go to the key. And certainly when I'm doing the key over here, I want to point out that we give you a key for a reason. People get stuck, and sometimes the key's helpful. Sometimes videos are helpful. Sometimes getting help from your teacher is helpful, all right? So like help from your neighbor is helpful. You might have to search around. But the more you do, the more you try, particularly at a younger age, the easier this gets. When you get older, though, it does become much more difficult to do competitive type exams. People just get slow. That's what happens, all right? So I think I did the same thing here. Yeah, I did. Over there, again, that's the way I saw it. Again, if you see something and you want to tell me something, that you saw something different, please share with me. If you want to share with me, my email address is Bannon, B as in boy, add the @ symbol, NNON.US. And please, if you find another way, share it with me. I would love to see it, and I would type it up. I'd put it into the answer key, and I'd probably put your name down. All right? If you want it down. If you don't want your name down, please tell me you don't want your name listed. All right? But I'd love to list people's names in my documents. I do it in my school notes all the time. Someone finds an error. They tell me they found an error. Their name goes down. In perpetuity, by the way. It's there forever. All right? And yeah, it really is. The internet's almost like a forever document resource. Okay? Thanks for paying attention. I really appreciate that. We've completed all 5 problems, and we'll move forward.